The energy theorems are developed to analyze the determinate structures. The determinate structures are with respect to jointed frames as well as rigid jointed frames. So in the analysis means here we are going to analyze what is the displacement at a particular joint with respect to the given loading system. So here if I talk regarding the displacement, that is nothing but deflection as well as rotation. So deflection we can also call it as translational movement. Translational movement. Uh, how to determine these deflections using this strain energy concept, which is using this strain energy concept, certain energy theorems are developed. Those energy theorems are strain energy method or real work method, virtual work method or unit load method. And the third one is Castigliano's theorem. So this Castigliano's first theorem is applicable for determinate structures. Another theorem is also available, that is Castigliano's second theorem, which is useful for redundant structures which are indeterminate. This Castigliano's first theorem is being used in structural analysis for finding deflection of an elastic structure based on the strain energy of the structure. This theorem we can apply when the supports of the structure are unyielding and the temperature of the structure is constant. It means that if the support is sinking, if there is any settlement of the support, then Castigliano's first theorem is not applicable. As well as there should be no change in the temperature. And if there is any change in the temperature also, then in the entire structure, then this theorem is not applicable. We can say that this is the limitation of this Castigliano's first theorem. Now coming to the next one, Castigliano's first theorem states that as per this Castigliano's theorem, the first partial derivative of the strain energy of the structure with respect to any particular force gives the displacement of the point of application of that force in the direction of its line of action. So in a short way, we can say that delta deflection at any point is partial derivative of strain energy with respect to the corresponding load acting at that point. So dou u by dou w, or you can also call it as dou u by dou p, where p is the load that is acting at the point where the deflection is required or the displacement of the displacement is required. Similar way, to get the rotation, we have to partial derivative the strain energy with respect to the moment that is acting at that point. Now, this Castigliano's first theorem is applied for deflections of pin jointed frames. As per strain energy concept, in an axial member, the strain energy stored is P square L by 2A. In a single member, the strain energy stored is P square L by 2AE, while the strain energy stored in the entire pin jointed frame is nothing but summation of strain energies for the individual members. And this Castigliano's theorem is saying that delta is dou u by dou p. Now do the derivation for this p square derivative is 2p, and this p is once again derivative. So dou pi by dou p into li. Li is the length of the member. So 2 and 2 are cancelled. You will finally get deflection at any point is sigma p k L by AE, where you are taking it as k is dou pi by dou p. And when you want to observe the deflection and rotation of the beams, here the strain energy stored in the flexural members U is equal to integration of m square into dx by 2ei. Now to get the deflection, partial derivative the strain energy with respect to the load. Now you will get the deflection delta is integration of 0 to L. The limits are 0 to L the m into dou m by dou p into dx by dx. Similarly, we can get the rotation also when you partial derivative the strain energy with respect to moment acting at that point, and this is the corresponding. So we have to remember these 3 points: deflection at any point for a beam jointed frame is sigma p into k into L by A. While for deflection in the flexural members, that is in the beams, delta is integration of m into dou m by dou p into dx by dA. While rotation theta is you are partial derivating the strain energy with respect to moment. Respect to moment. Now, just for an example, we considered one problem here. All of you please note down this. Calculate the vertical deflection at joint C. At joint C. Now here the Young's modulus E is given and area is 500 mm square. A into E is 10 into that is 10 power 5 kilonewtons. Axial rigidity AE is called as axial rigidity, and this is the frame that is given where 150 kilonewtons load is acting at B. 150 kilonewtons load is acting at B. Here in the question what they have asked us, they asked us to calculate what is the deflection at C. So to get deflection at C, we are applying a fictitious load capital P, and initially it is applied where the deflection is required. So as per Castigliano'S theorem, wherever deflection is required, apply load in the same direction. Now, first of considering this capital P plus 150 is the downward load. The reactions are RA and RD. Considering sigma Fy equal to 0, we got RA plus RD is equal to 150 plus P. And while taking moments about A, sigma M about A is equal to 0. And it will give minus RD into 15, that is anti-clockwise, plus P into 10 clockwise, plus 150 into 5 equal to 0. Now RD is the reaction, which is 2/3 of P plus 50, and RA plus RD is 150. Substitute in this equation, you get RA, which is 100 plus P by 3. Those who are not there in the previous class, please note down up to this one. Just I will wait for few minutes so that you people, those who missed in the last class, please note down. So in the today's class, we are discussing regarding Castigliano'S theorem. I think some of you might have not noted the above points also. Shall I need to wait for anyone? Please respond. Otherwise, we can move quickly. These points are discussed in the previous class itself. Can I move further or shall I show you this one? If you people have noted down all these points, we will go to the problem. Nobody is responding. Maybe people are not responding. I am asking something. Okay. Only 1 or 2 are responding. It's not a good way. If you have not noted down in the previous class, please respond so that I can wait for you people. Otherwise, we can move further. Just note down this problem. Those who joined today only, please note down this problem. Can any one of you respond who is not there in the previous class and presented today? who is not there in the yesterday's class and presented today? Yes. Okay, Rachna, please note on this problem. Please note down. Lokesh, no problem. Just note down this question quickly and I will wait. Still, many of you didn't submit your assignment. 19 series 142, Srija, have you submitted your assignment? 19 series 131, Mavia, have you submitted your assignment?
Yes,
140,
sir, submitted.
you submitted.
Yes, sir, submitted.
Okay, I will check. 143, Shravya, Vishnu,
Submitted,
Yes, sir,
sir.
submitted.
I didn't find. Where did you submit? You submitted through Google Classroom?
No, sir. Gmails.
Lokesh, what about you? Did you complete the noting on the problem? Where did you submit? What is your mail ID, Vishnu?
Sir,
What is your mail ID, Vishnu? Did you submit?
Kurmachalam mission will be KURMA, Kurmachalam mission will be there. Sir. KUR.
Oh, Vishnu, I didn't receive. To which mail ID did you send?
Sir, Madhuru Sriram at the rate of ski.ac.in.
No, I didn't receive. That's why I asked you. Just once again, check it and send me once again.
Okay, sir.
Similarly, Shravya,
Okay, sir.
yeah, Shravya also, I didn't receive, ma. I didn't
Sir, I
receive
have sent through Google Classroom.
Google Classroom. Just wait a second. Yes, I received, ma. Received.
Okay, sir.
Yeah, Mavia also, I received, ma, Mavia.
Okay, sir.
For Tarun, 185 Tarun. Tarun, you uploaded in the Google Classroom, I think. It is the attachment is missing. Attachment is missing. Tarun, please check it. Once again, you send to the mail ID if possible. Okay. Now, after writing sigma Fy equal to 0, we take moment about A is equal to 0 actions RA and RD. Nineteen series 142. Sri Rama. Can you respond, Sri Rama?
Yes, sir.
Yes, ma'am. Just once switch on your video and show me your notebook. You open your video. Just let me see the structural analysis notebook. Why you people are fearing when I ask a number? She left the class when I asked her to open the notebook. I'm not just scolding anyone or shouting. Just whether you people are following it or not, let me know so that I can help you. There is nothing wrong if I ask to open the notebook. Okay. Now, after getting the reactions, now we have to move to the forces. Why? Because here we need to get deflection at C. So deflection at C is nothing but sigma P K L by E. So here P is nothing but force in the individual members. So to get the force in the individual members, now we have to first determine using method of joints. So using method of joints, analyze them. Here joint A is available. At joint A, there are two forces are there. Force in AE, force in AB. Now, an inclined force AE is to be resolved along horizontal axis FAE cos 45, vertical one FAE sin 45. So, FAE cos 45, FAE sin 45, they are resolved. Consider sigma Fx is equal to 0, sigma Fy equal to 0. Now, using this, sigma Fx is equal to 0, Fab plus FAE cos 45 equal to 0. Sigma Fy equal to 0, FAE sin 45 plus RA is equal to 0. Now we will get the force in AE, which is minus root 2 into 100 plus P by 3, which is compression. Which is compression. FAE, force in AE is determined. After getting force in AE, we need to get force in AB. So to get force in AB, substitute this AE value in the above equation. From this equation, we will get force in AB, which is 100 plus P by 3. And this is tension. Who is a friend of Varsha here? 158 Varsha. Is there anyone who knows Varsha? Any one of you know Varsha or not? Nobody is there. After getting the free body diagram at joint A, move to joint E. So at joint E, here forces are FAE, then FBE, FEF. This inclined force FAE is resolved vertically as well as horizontally. FAE cos 45, FAE sin 45. So you will get sigma Fx is equal to 0. FEF is positive. FEF minus FAE cos 45 is equal to 0. Substituting FAE value here, we will get FEF as minus of 100 plus P by 3. And this is compression. Negative is indicative of compression. And sigma Fy equal to 0. Substituting sigma Fy equal to 0. And the downward forces are minus FAE sin 45 minus FPE is equal to 0. Here once again substituting FAE value, we will get FBE as 100 plus P by 3, which is tension. which is tension. Till this completed? Yes. What about Lokesh? Yes, okay. Now let us move to joint B. Let us move to joint B here. After writing the free body diagrams at the joint A as well as at the joint E, now free body diagram at joint B. Here, how many forces are there here? At joint B, a downward force of 150 kilonewtons is acting. Here, force in BC is there, and AB member is there here. We are assuming all the forces are in tension. That's why away from the joint we are representing. This is force in. Now, inclined force is to be always resolved. Just wait a second. At joint B here, the forces are written, and the inclined force is to be resolved. Yes, Monica, you have raised your hand. Any doubt, ma? Yeah, 20 series 175. Please tell me.
No, sir.
Nothing. Okay, right, fine. So at joint B, the forces are represented, and these forces are the force in BF is resolved along horizontally, FBF cos 45, FBF sin 45. Now taking sigma Fx equal to 0 minus FAB plus FBC plus FBF cos 45, the horizontal forces are written. And while sigma Fy equal to 0 plus FBE plus FBF sin 45 minus 150 equal to 0. This force 150 is acting in the downward direction. Now we know the value of FBE. Substitute here to get FBF value. So substitute that value 100 plus P by 3 plus FBF sin 45 minus 150 equal to 0. And if we simplify this, we will get the value of FBF, which is nothing but root 2 2 into 50 minus b by 3, and this is tension. So we got FBF value. Substitute this FBF value in this equation. We already know AB value. What is AB? Force in AB, just here 100 plus P by 3. Substitute there. So this is minus 100 plus P by 3 plus FBC plus root 2 into 50 minus P by 3, 0. Root 2 is cancelled here. So force in BC is to be obtained. This is minus 100. It will go in the right side, which is 100. Minus P by 3, this will go plus P by 3. This 50 minus P by 3, minus 50 plus P by 3, which is 100 minus 50 is 50 plus 2P by 3. So FBC value is 50 plus 2P by 3, which is tension. So force in BC is tension. 50 plus 2P by 3. Now, after writing this free body diagram at joint B, we will move to the free body diagram at joint D. Remember, in this method of joints, we know that whenever the number of unknowns are less than or equal to 2, there only we will consider the joint. And there the free body diagram is written. At joint D here, reaction force RD is there, force in CD, force in DF, and this is 45. FDF, this is cos 45. FDF sin 45. So this is FDF cos 45. This is FDF sin 45. Now, writing down sigma Fx equal to 0 minus FCD minus FDF cos 45 equal to 0. And writing down the equation of sigma Fy equal to 0 plus FDF sin 45 plus RD equal to 0. We already have calculated what is the value of RD, which is RD value is 50 plus, what is the value of RD? 50 plus 2/3 of P. So FDF into 1 by root 2, sin 45 is 1 by root 2, RD is 2/3 of P plus 50 equal to 0. You will get FDF as third of P plus 50, and this is minus root 2. This is completion. Minus root 2 by 3 plus 50 is force in DF. Substitute this value in this equation. So minus FCD minus of minus root 2 into 3 by 3 plus 50. So that is minus into minus plus. This is into actually it is again. Cos 45 is also to be written. 0 cos 45 is 1 by root 2 here. So this 1 by root 2 and this value is cancelled. So if you write down this one, FCD is what is the value of FCD here? 2E by 3 is positive. This is tension. Do the simplification perfectly so that no error will occur. If you change negative to positive or positive to negative, entire problem will be disturbed. Now, the remaining force that we need to get is only force in EF. Only force in EF is remaining, all the other forces are determined. Now, write down free body diagram at C. So, when you draw the free body diagram at C here, this is force in CD, this is force in BC, force in CF, a downward force of atom is acting. We require only force in CF. That's why I will take sigma Fi equal to 0. That's it. Take sigma Fi equal to 0. So plus FCF minus P equal to 0. So FCF equal to capital. So FCF is equal to capital P. If this is completed, we'll move further. Just give a response. So now what we have done till now, we calculated what are the forces in the members due to external load system. That is 150 kilonewtons is the load that is acting at B, and a fictitious load is applied at C. This fictitious load, why we have applied? To do the partial derivative. So as per Castigliano'S theorem, to get the deflection at C, as the load is not available at C, we have applied a fictitious load. So deflection at C, delta C is equal to dou U by dou P, and this is nothing but sigma P K L by P. Sigma P into K into L by P. Just prepare a tabular form. Like this. In this one is member length. This is capital P. This is dou P by dou P into dou Pi by dou P. This I is a Pi and P1, P2, P3, the forces in the members. And you are doing partial derivative L by AE. L by AE. Now L, length of the member, we are writing in terms of meter, force in kilonewtons. Here, what is the member, first member? First member, AB is the member here, first member. Then AE, BC, EE, PF is member here, CD, CF, F, as well as EF. So these are the total members. Now write down the length of the members. Here, the members AE, BF, DF, they are inclined. So that's why that is inclined members. Just go to the diagram and see what is the length of the members. Each member, horizontal member and vertical members, they are given as 5 meters length. They are given the length as 5 meters. Whereas AE member, this is inclined, which is square root of 5 square plus 5 square. What is the value of this one? Square root of 5 square plus 5 square.
7.07
Yeah.
meters, sir.
Right. So this is 7.07 meters. Similarly, this is also 7.07 meters. This is also 7.07 meters. So represent the lengths of these members, and the remaining all are 5 meters only. Write down what is the length of the members. The length of the members. This is 5, 7.07, 5, 5, 7.07, 5, 7.07. DF is 7.07. This is EF is 5 meters. Now similarly write down the forces in the members also. FAB, FAE, FBC, all the forces. I'm just writing down the summarizing all the forces here, the tabular form. Represent with sign also. Check whether the values are accurate or not. Force in CF is capital B, and this is minus 250 plus 230 minus 100 minus of 100 plus P by 3. So this is the force that is there in the members. Now what we are doing is small k is nothing but dou P by dou P. That is, you are derivating the forces in the members with respect to P. Now, what is 100 plus P by 3? What is the derivative of this one? 100 is constant, that's why it is 0. Derivative of P by 3 is 1 by 3. This is minus root 2 into 1 by 3 is the partial derivative. We are doing the partial derivative of this one. So this is P by 3 into is the partial derivative of P by 3 is 1 by 3. So this is minus root 2 by 3 by 3. This is 1. This is minus root 2 into 2 by 3 minus 1 by 3. Now here, what we will do is we are writing the P into dou P I by dou P into L by AE. So it means that here we already know that the value of P, what is the value of P here? It is a fictitious load you applied at C, which is equal to 0. Now make that value as 0. So this term, P term will be equal to 0 here. So just keep a note here. That is nothing but P is equal to 0 as there is no load. As there is no load, hence you have to make it to 0. So when you are making them into 0, so this term will not be there. That is 0. This is not there. This term is not there. This term is not there. This term is not there. And this is also made to 0. 0. This is made to 0. Why? Because the fictitious load applied at C, that is 0 only. Now 100 is the value of P, and this dou P by dou P is nothing but 1 by 3. So just check P into dou P by dou P into L by AE. So PK L by AE value is to be determined for each and everything. Here, length of the member is to be substituted in terms of meters or mm. We are substituting in terms of meters. So force in kilonewtons, axial rigidity. What is the axial rigidity? Just check in the question. Axial rigidity value. What is there? Area is 500 mm square. E value is 200 kilonewton per mm square. So AE is 200 into 500 kilonewton per meter per mm square into mm square. So the unit is in kilonewton. So 1 into 10 power 5 is kilonewton. Substitute 1 into 10 power 5 for AE. So 1 into 10 power 5 for AE value. AE is 10 power 5 kilonewtons. Load is in kilonewtons. Length is in meters. So the entire PKL by AE units are in meters. And I am just writing down the answers of this. Just check whether you got the same answers or not. So force multiplied with K into length of the member by AE. We got this result. Here this is 0. As the P value is 0, this is 0 only. Please be consistent with your units. And we got the value sigma P K L by E as 0.01539. Please check this whether you got the same thing or not. Now here, yes, once again I am giving you a time. Please check it whether you got the same answers or not. And finally, this is nothing but delta C only. This is in terms of meters. The answer is to be obtained in terms of mm. If I say, then multiplied with 1000. So 15.39 mm is the deflection at C due to the external load acting at B. If this is completed, please let me know. We can go to the next problem. I hope this is completed. Let us move to the next problem. All of you know the next one. We will solve another pin jointed perfect frames only. Out of the question. Just on this one.
Sir,
Yeah, tell me.
sigma pkl by a 0.013.72 meters వస్తుంది సార్.
No, is the answer wrong? All of you, please let me know whether the answer is correct or not. Those who have done the problem, please let me know whether the answer that I have shown is correct or wrong. Rahul, I think he is saying that the answer is not correct. మీరు ఎంత స్లోగా రెస్పాన్స్ ఇస్తున్నారు ఎందుకు? ఇట్ ఈస్ వెరీ టఫ్. మీరు రెస్పాన్స్ ఇవ్వకుండా ఉత్తినే సైలెంట్ గా కూర్చునేదైతే క్లాస్ లో ఉండటం బెస్ట్. ఏమైంది మీకు? ఏమైనా నోట్లో
15.39 mm సార్.
ఆన్సర్ ఇవ్వడానికి నొప్పి ఏంటి చెప్పండి. మీకు ఆన్సర్ ఇవ్వడానికి నొప్పి ఏంటి? నేను స్మూత్ గా
Sir,
క్లాస్
correct,
చెప్తున్నాను.
sir.
Rahul, you check that answer?
Checking, sir.
Yes, slightly they might be. నేను ఇదే క్లాస్ కాదు, మీరు మార్నింగ్ క్లాస్ లో కూడా చూశాను. Nobody is responding. If you are not interested with the class, just leave. This is not the way. మీరు ఏం చేస్తున్నారో తెలియదు. మేమేమో మిమ్మల్ని అడుగుతూ ఉంటాము హలో హలో అని, మీరేమో మాట్లాడు నెంబర్ పిలవగానే ఎగ్జిట్ అయిపోతారు. Please respond whenever I am asking, or not only me, if particular faculty is asking, if you know the answer, if you don't know the answer also, you can say that yes sir, I don't know the answer, please repeat once again. Let us move to the next problem. Find the vertical deflection of the joint find the vertical deflection of the joint C of the loaded truss shown in the figure. The cross-sectional areas of members CD and DE are each 2500 mm square, and those of other members are each 1250 mm square. Take E equal to 200 kilonewton per mm square. In the given truss, I'm just drawing here. Here the supports are like this. This is support A, this is support E, A is hinged one, is roller support. This is B, and here a point load of 40 kilonewtons is acting. This is C. Here this is making a 30 degrees angle here. Now D, C, D, E. Now here this distance is given as 2 meters. This distance is given as 2 meters. Now see here, that's it. This is given in the question. Nothing is mentioned. We are asked to calculate the vertical deflection at joint C. And here you know a vertical load of 40 kilonewtons is acting. First, in the first step, what we have to do, we need to calculate what are the reactions at A as well as reactions at E. Reactions are to be determined at A as well as E. So in this case, here the reactions are, I will write down this as RAX, and this is vertical one, RAY. Here this is RE. Roller support is having only one reaction and 2 degrees of freedoms are available at roller support. Whereas at the pinged support or hinged support, degrees of freedom are 1 and the reactions are 2. Take sigma Fx equal to 0. That implies here Rax plus Re equal to 0. Rax plus Re is equal to 0. While sigma Fy equal to 0. Your vertical reaction RAY is there. RAY minus 40 kilonewton is equal to 0. So RAY equal to 40 kilonewtons. RAY is 40 kilonewtons. So before calculating that, here you should understand what is this distance. It is not given in the question. So how to get this question, this distance? Already the vertical distance 2 meters is mentioned. That is, member AE length is 2 meters. Member AE length is 2 meters. Now take tan 30. Tan 30 equal to opposite side AE by AC. The entire triangle ACE we are considering from triangle ACE. Tan 30 is equal to AE by AC. I want the value of AC. AC is AE by tan 30. So AE value is already mentioned, which is 2. So 2 by 1 by root 3. Tan 30 is 1 by root 3. So 2 into root 3. 2 into root 3 is the entire distance. 2 root 3 meters is the distance of entire AC. But it is equally distributed. So that's why AB and BC are at half of that one. This will be 1 root 3. This is 1 meters. See, don't say that the dimensions are not mentioned. The angle is given. From that angle we are determining. So what is this one? This will become 1 meter here. So this is 1 meter. Now can you tell me what is this distance? What is this distance? This is root 3. This is 1. So root 3 square is 3. 3 plus 1. That is root 3 square. That is, it is looking like a triangle only. Or you can also take sine 30. Sine 30 is 1 by 2. So this will become 2 meters. This will become 2 meters. Now, whereas this will also become 2 meters only. Why? Because if you consider this as a triangle here, this is 1 meter, this is 1 root 3. So this will become 2 meters. This will become also 2 meters. 2 meters only. Now we have determined what are the dimensions. What are the dimensions of this truss are determined. Now calculate moment about A is equal to 0. Now taking moment about A is equal to 0. You take moments about A is equal to 0 here. That implies, can any one of you tell me what are the moments about A is equal to 0? When
Minus
you
40
take,
into
yes, okay, you are considering clockwise as negative, but anyway, I will
and
consider clockwise as positive. Plus 40 into the
2
distance
root
is
3
2 root 3. So the moments when you take about A is equal to 0 plus 40 into 2 root 3, this is
minus RE
anti-clockwise, minus RE into 2 equal to 0. So this will give you the value of RE, which is 40 into root 3. Just do the simplification, you will get the value of RE.
69.28.
Yeah, I will keep in root 3 only. Why? Because the decimals, everything we'll see at the end. Okay, the value is 16.28. Okay, we'll write down the same thing. That is RE 69.28 kilonewtons. So this is when you take moment about A is equal to 0 plus 40 into 2 root 3 minus RE into 2 is equal to 0. And RE value is 16.28 kilonewtons. From sigma Fx is equal to 0. From here, RAX is negative minus 69.28 kilonewtons. Minus 69.28 kilonewtons. Now go for any joint. If you go at a joint A, then what happens are there are 3 members are there. The 3 member forces are unknowns. So that's why go to the free end. At the free end, there are only 2 forces are there. Start analyzing either from joint C or joint E. Here at E also we have 2 forces. So that's why I will start with the free body diagram at joint C. Write down free body diagram at joint C. So at joint C here, this is force in BC. Inclined force is there, which is force in CD, that is which is making an angle of 30 degrees with respect to horizontal. And a 40 kilonewtons load is also acting here. But before here, just please make a correction here. Just please wait. Please wait. Let me erase one point. I missed one point here. Let me explain that one. After getting the, just we missed one point. Please wait a second. Please wait a second here. Small correction is required. Here, before going to the reaction calculation, I forgot to tell you one point. What happened is here, wherever to determine the deflection, in the question what they said, they asked us to calculate the deflection at C. So obviously at C there is a load 40 kilonewtons is acting. So if this load 40 kilonewtons is not acting, we might have applied a fictitious load. Already a 40 kilonewtons load is acting. This is to be replaced as capital P. Castigliano's theorem. Wherever we require the deflection, there the load is to be applied and that load is to be represented as P. So, just represent. To get deflection, now write down. To get deflection at C, apply a load P in downward direction. So what is this value of P here? Here P is equal to 40 kilonewtons. In the previous, P is not there. The load is not there. We applied a fictitious load, but here we replaced 40 kilonewtons with a term capital P. At the end, now we will substitute that P is nothing but 40 kilonewtons. That's very, very important. Now, this load is not already acting. That load is to be replaced with capital P, which is 40 kilonewtons at the end. Now, considering this, now just once again draw the frame. Here, this is capital P. This is A. Here, reactions are acting, which is RAX. And vertical force is there, which is RAY. This is RE is acting. This distance is root 3. This distance is root 3. This is 1 meter. This is 2 meters. This is 2 meters. This is 2. And this is 2. Here, the joint C. This is B. Here. Now, what we have done is, as per Castigliano's theorem, wherever the deflection is required, there a load is to be considered. That load we are considering it as capital P. Already in the external load system, 40 kilonewtons is acting. That's why this P is equal to 40 kilonewtons. Now, take sigma Fx equal to 0. That implies plus RAX plus RE equal to 0. Sigma Fy equal to 0 plus RAY is the upward force minus P equal to 0. RAY equal to capital P. So entire loads or the forces in the members are to be represented with respect to capital P. As you are derivating the strain energy, dou U by dou P you are doing. That's why all the terms should not be represented numerically. They should be represented with P. Taking moment about A equal to 0 minus RE into 2 plus P into 2 root 3 equal to 0. So the value of RE is P into root 3. Whereas the value of RAX is minus P into root 3. Minus P into root 3. This is the one that the correction is to be done. All of you please make the corrections. With this, now you calculate what are the reactions in each member. What are the reaction forces in each members? You please calculate that and prepare the tabular form. After doing the tabular form, then complete the deflection, which is sigma pkl by ae. Please do this problem. If you are able to do it and get the answer, that's happy. Otherwise, I will continue in the next class. Please remember once again, I repeat, here, wherever we require the deflection, there we have to represent with a notation capital P or capital. This is to be done for the derivative part. And at the end of the problem, if the load is not available, you apply a fictitious load, you make it to 0. Otherwise, here in this problem, external load is already available. Substitute capital P is equal to 40 kilometers. That's it. Okay, let us continue this problem in the next class. And now, as of now, the class is completed. The attendance is noted down. Attendance is noted, I think. People can leave.